All right, let's talk about how it can do with the TI83, and we're doing chapters 8, 9, 10, and 11. 8, 9, 10, and 11. So let me show you how the TI83 does all that stuff. If you're taking the TI83 final, this will be, introduction, how to do all that stuff with the calculator. So this is review sheet 3, chapter 8, 9, 10, 11, TI83 review sheet 3. And I'll do a couple of problems in here, the new stuff. The old stuff, hasn't changed, so you can go back and look at the old lessons on that if you need to. So here we're going to see, number one, we want to see if there's a difference. So the key word is difference between grocery prices at Raley's and SPD. We compared the prices for the same item at the two stores. Results are listed below. Does this imply a difference in prices at the two stores at a 93% confidence level? So 93% confidence level means alpha is going to be 0.07, right? So you can fill that in right away. If there's a difference, that means that, Raley's is different than SPD, right? That's a difference. And that means that Raley's minus SPD would be not equal to 0. And because these two stores, these two items, the two sets of data here look like they're related, compared prices for the same item at the two stores. So this number goes with that number goes with that number. The data is paired or matched. It's dependent, two dependent samples. So we're going to use, we're going to take this Raley's minus SPD and make it into a D. So I'm going to call that the D column. So right here, I'm going to have a D column. And the D column is not going to equal 0, specifically the mean of the D column. So you have to write your hypotheses like that. The mu of the D's is not equal to 0. And that means there is a difference. So that is our alternate hypothesis. The mu of the D's is not equal to 0. So we can or cannot, we'll write our conclusion right away, be 93% confident. There's a difference confident. There's a difference in prices. Okay, so that means the two columns are not the same if there's a difference in prices. Okay, so that's the alternate hypothesis. That's rule number 4. Our conclusion is always based on the alternate hypothesis. Okay, now what we're going to do here is we're going to put the data into the calculator, which is nice. We don't have to do this by hand. So I'm going to go to stat edit, and in L1 and L2 I'll put the data. So let me clear out L1 and L2, put the cursor at the top and push the clear and the enter key to clear the data out of a column. So I'm going to put in Raley's prices in L1, and then I'll put SPD prices in L2. All right, and then to get the D column, we're just going to go to column 3, L3, put the cursor at the very top and put in L1 minus L2. So you got to put your cursor at the very top of the column, and then it'll fill that column in for you. So here's our D column automatically filled in by the calculator. So now what we're going to do is we're just going to do a t-test on that D column, a two-tailed t-test. Notice it's two-tailed. So we're going to do a two-tailed t-test on L3. So we go to stat tests down to t-test, and we have data. Notice our mu0 is 0. So mu0, the number in the alternate hypothesis, is a 0. So we put a 0 in there. And it is L3, so second L3 for the list. And make sure you highlight two-tailed and then calculate. So our t turns out to be 2.03. The p-value is 0.098. And of course, alpha is 0.07. 93% confident means alpha is 0.07. 0.098 is what our p-value turns out to be. So because our p-value is bigger than alpha, that's a cannot. Okay. So we were not able to be 93% confident that there's a difference in prices based on this little sample here. Okay, so that's two dependent samples on the TI83. Next comes to independent samples, Feminist Coalition. So this is number 2 on review 3. Feminist Coalition claims college women's GPAs are higher than men's GPAs. So the claim is that the average for women is greater than the average for men, right? The women's GPA is higher is the claim. We randomly survey 15 women, find their average GPAs to be 11 men have GPAs like this. Is the coalition correct with 99% confidence? 99% confidence means that alpha is going to be 0.01. So this is going to be a 2-sample t-test. We have 2 independent averages. Whereas up above, we just use the regular old t-test. So it's going to be a 2-sample t-test. Let's see here. So we think that the women is greater than men. That means if I bring the men over, it's going to be mu women minus mu men is going to be greater than 0. So it's going to be a right-tailed test. We'll call women sample 1 and men sample 2. So let's put the numbers in and see what happens. And what you do here is you put the numbers into L1 and L2, wherever you'd like to put them. So I think I'll put them in L1 and L2, clear out L1, clear out L2, and then you enter all those numbers. So this is going to be 2, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 threes. And then 3 fours. For the women. And then for the men, I'm going to put in 2 1s, 1, 2, 3, 4, 5 2s, 1, 2, 3 3s, and a 4. And that is, what do we say, 15 women. So that looks about right. And 11 men. So we put the data into L1 and L2. Notice it's not the same in each column. You do have to remember that L1 is the women, L2 is the men. When we do our sample, it's going to be L1 minus L2, and it's going to be a right-tailed test. So, we do have to remember that. Okay, so if you want, we can write the conclusion right away. We can or cannot be 99% confident women's GPAs are higher. Okay, so that's what the alternate hypothesis says. Rule number 4 says always write your conclusion about the alternate hypothesis. All right, now this is pretty easy. We go to stat, go to tests, scroll down to 2-sample t-tests because there's 2 independent samples, and we don't know population standard deviation, so we're going to do a t-test. And then it says we're going to do data, not stats. The data is in L1 and L2. And down here, this is critical. It says mu1, and then it's got a not equal to mu2. That'd be a 2-tailed test. Mu1 less than mu2. That's not correct. And then lastly, the right-tailed test, mu1 is greater than mu2. Highlight that and push enter. And then we're always doing not pooled. So scroll past that down to calculate, enter, and it tells us our answer. So our T is 2.54. And our p-value is 0.011. 0.011. So again, because p-value is bigger than alpha, that's a cannot. So men were saved we almost, we're 99% confident that women's GPAs are higher, but we cannot be 99% confident women's GPAs are higher. I made up that question, of course. Okay, number 3. Sac State claims its business graduates earn more than CSU Chico business graduates. So the mu for Sac State is greater than the average salary for Chico. So if I bring this over, it's going to be mu Sac State minus mu Chico greater than 0. Right-tailed test. And in this case, I gave you the numbers so you don't have to enter the data. So up here in number 2, we had to put the data in L1 and L2. In this case, we're going to use stats, and I just gave you what X bar and S were. So this means, we can or cannot, or conclusion, based on the alternate hypothesis, be 97% confident that Sac State graduates earn more. MBAs, grads. Okay. So let's go, and you just go do the test now. So I'm going to go back to stat tests, down to 2 sample t-test again. And now we're going to do stats. So instead of data, we're going to go over to stats. So I gave you X bar and S, so we can just put the stats in. And remember, it's important that we call Sac State sample 1 and Chico sample 2, keep straight, which is greater. So I'm going to put in X bar 1 has got to be Sac State, and that'll be 34,000. And the standard deviation is 2,700. And there were 60 of those. So let's put 60 as our N. X bar 2 is going to be 31.5. And standard deviation 3,300. And there were 45 of them. Now do a right-tailed test. Make sure that's highlighted. Pooled, no. And finally calculate. So I got a T of 4.14. Really 4.15. Our alpha rather is 0.03, 97% confidence. And our p-value, this is tricky, so be careful of this. A lot of people get this wrong. It looks like the p-value is 4.03, but it's actually 4.03 times 10 to the negative 5th. So there's a little -5 over there. So what that means is 1, 2, 3, 4 zeros in front of the 4. So this is a very definitely, our p-value is a lot smaller than alpha. So this is a can. We can be very sure that Sac State grads earn more. Okay, next, number 4, Berkeley claims a greater percentage. So here's a claim about a percentage of its pre-med students get into med school than Stanford pre-meds. So we think the percentage of Berkeley students is greater than the percentage of Stanford students, right? P Berkeley greater than P Stanford. You got to have P's when you're talking about percents. When I bring this over, I'm going to get P Berkeley minus P Stanford greater than 0. So it's going to be a right-tailed test. And this is pretty easy. And if you want, you can write your conclusion right away. We can or cannot be, what's our confidence level? 97% confident. And you got to say in your conclusion a greater percentage, okay? Make sure you mention the word percentage in your conclusion about a percent problem. 97% confident. Do not say more. Do not say more. A greater percentage of Berkeley students get into med school. Okay. All right, now watch how easy this is. So I'm going to go into stat tests again. And now you got to go down to proportion, down number 6, to proportion Z test. And it says, okay, what's x1 and x2? And be careful you do it in the right order. So Berkeley is going to be first, Stanford is going to be second. So P1 and P2. So when I do x1, I just put in how many, 81 out of 150. So x1 is going to be 81, the n was 150. Whereas for Stanford, it was 99 out of 225. It's a right-tailed test, so highlight that. You can tell that from the alternate hypothesis, and then calculate. And I got 1.898, so that's really 1.90 is our z. Alpha, if we're doing this at 97% confidence, alpha is going to be 1 minus 0.97, which is 0.03. And then our p-value is 0.029. 0.029. So p-value is a little bit smaller, so that is a can. So we can be 97% confident a greater percentage of Berkeley students get into med school than Stanford students. Okay, so that's 4 problems on the first page. I think what we need to do now is do the second page. So on the second page, there's an ANOVA. Number 7 is an ANOVA. And these are ridiculously easy. All you have to do is put those columns into L1, L2, and L3. So let me do that. I'm going to go to Stat, Edit, clear out the stuff that's in there. Put the cursor at the top and here, clear and enter. Hit clear and enter. Okay, here's the first column, A, airline A, 1, 2, 3, 4, 6, 7. And the second column is 1, 2, 3, 4, 6, 6, 8, 10. And then last column, 1, 1, 1, 3, 4, 4. Okay? So you put the numbers in, L1, L2, and L3, and then all you have to do is go to Stat, Tests, go up from the bottom. ANOVA is the very last menu, very last choice, so push Enter. And then you put in L1, comma L2, comma L3, and Enter. And it does everything for you. So our F turns out to be 1.99. For ANOVA, the H1 is always, at least one average is different. At least one average is different. Alpha and our p-value. Alpha, we're doing this at a 90% confidence level, so alpha is going to be 0.10. And our p-value is the second number on the screen is 0.167. So 0.167 is bigger than the alpha, so it's a cannot. So we cannot be 90% confident. At least one average is different. At least one airline's average age is different. Okay, so that's ANOVA, really easy. You don't have to add up columns or do any of that stuff. The calculator does the whole thing for you. If you're interested in, what those numbers are, you can scroll down here and it lists all the numbers, but you don't really need to write them down or use them. Okay, let's do linear regression. This is also easy. So this is number 8 on review worksheet 3. We've got drugs tried and college GPA. It's a correlationship between drugs tried in college, or maybe in your life, and your college GPA. So I gathered some data here, made up some data. So let's put it into L1 or L2. So let's go L1 and L2. And you just enter the numbers. So 0, 0, 2, whoops, I kind of blew that one, sorry. 0, 0, 2, 3, 4, 5. And the other column, I got a 0.2 in there, not 2. In the other column, it's going to be 4, 3, 3, 2, 0, 0. All right? So you enter your numbers in L1 and L2. Make sure you put them in the right order. And then let's do linear regression. So all you do is go to Stat, over to tests and up from the bottom, because it's all the way at the bottom, linear regression t-test. Don't do a linear regression t-interval, do a linear regression t-test. Push enter and it says which columns, and I say L1 and L2. You want to make it a two-tailed test, so do not do a right-tailed test. It's plus or minus, so not equal to 0. Regression equation, if you want to plot the regression equation, there's a way to do that, and I can show you how to do that if you really want to. But I'm just going to go right to calculate. So it tells us our t-value. So the t-value, and of course the hypothesis down here is rho is not equal to 0. That's the alternate. That means there is a correlation. Our t-value is negative 4.90. Alpha here is, we're doing it 95%, so alpha is 0.05. And our p-value is 0.99. And that's because I must have screwed up when I entered that. Let me go back and think about that. So anytime you get a big p-value like that, you must have done something wrong. So let me go back and find that. Let me go back to stat, tests, and linear regression t-test, L1, L2. So what I didn't do was I didn't select two-tailed. So make sure you select two-tailed. I don't remember selecting right-tailed, but you always want to select two-tailed for us, right? And then calculate. So anytime you get a big p-value with a calculator, you've probably made a mistake. So it's a good thing I made that mistake. Okay, the p-value turns out to be 0.008. Of course, that is a can. That's way smaller than alpha. So can be 95% confident drugs tried and GPA are correlated. Okay, so that's that. I think that's every test that you're responsible for. All the others, some of them you have to do by hand. So you have to do the non-parametric test by hand. There's 4 non-parametric tests. You have to do all those by hand. Number 6 is a chi-squared goodness of fit test. That you have to do by hand. And these others you can do on the calculator, but the chi-squared and the non-parametric tests from chapter 13, you do have to write those out and do them by hand. So even if you're taking the TI83 test, you'll still have to do that by hand, just like we're going to do in class. So I think that's everything new. There were 2 independent averages, 2 dependent averages, 2 proportions from chapter 8, regression and correlation from chapter 9. I didn't plot the, I should show you that though while I'm thinking about it. I didn't plot the line of best fit, but it is in the calculator. So let me scroll down and show you. If you scroll down, it'll tell you what the line of best fit is, tells you what the correlation coefficient is and all that stuff. So the line of best fit is negative 0.75 x plus 3.75. The centroid you can get from 2 variable statistics. So you should plot this 1, 2, 3 and a quarter, goes down 0.75 each time. So it kind of looks like this. And you should plot that line. It's a nice line. You should put the data in there. So 0 and 4, there'll be a triangle up there. 0 and 3, 2 and 3, 3 and 2, 4 and 0, and 5 and 0. So it looks like that. If you want to find the centroid, if you go back to stat, calculate, and go to 2 variable stats, and tell it you want to do 2 variable stats on L1, comma L2, it'll calculate X bar for you, 2.333. And scroll down, it'll do Y bar. Y bar is 2. So right here, 2 1/3 and 2, right about there, there's going to be the centroid right there, okay? Make sure you label that. You got to label the centroid, so X bar, comma Y bar. So remember 3 things on your graph: the data, the line, and the centroid. So the line of best fit, negative 0.75 plus 3.75, centroid 2.3 and 2. And the calculator will tell you all that stuff. Okay, so that's it. All the new stuff. This is review worksheet 3, TI83, chapter 8, 9, 10, and 11, TI83 review 3. So pick that up if you don't have it. Let me know if you have questions. Good luck.